Okay, so in this question we're asked to solve for the tangential acceleration of roller B, and the only piece of information we're given is that point A has a velocity of 1.2 meters per second downwards, and we are told to assume that the motion is constant over a small motion interval. So meaning the velocity of A is constant in this case. So we're first gonna start by writing the entire acceleration equation. So we're gonna write the acceleration of A is equal to the acceleration of B plus the acceleration of A relative to B, right? Cool. So we can then decompose this further into the acceleration of B plus alpha AB crossed with R plus omega AB into omega AB crossed with R, right? So we can find omega AB by solving for the velocity between A and B. So if we can solve this velocity problem where we have VA is equal to VB plus VA relative to B, omega AB is in this relative term over here. And then the problem is the acceleration at B. And we also don't know the angular acceleration of AB. So if you look at point B, right, point B has to travel along this arc over here, right? So in doing so, it's basically going through fixed axis rotation about the center, because you essentially have a line like this which connects the center, which I'm going to call point O, to point B, and at every single point, so let's say at a time t2, for example, point B moves to this position over here, the line is going to become like that, and the distance from the line doesn't change, which shows us that it's going through fixed axis rotation around the center, right? So knowing that, we can write another acceleration equation. So the acceleration of B is equal to the acceleration of O plus the acceleration of B relative to O. And you'll be able to do this for any situation where a point is moving around a center in a circular manner. So this is point B is basically rotating in a circle, kind of in an arc almost. So if you have a situation like that, then you can use the center point of the circle, and you can use fixed axis rotation to get more information to solve the problem. So yeah, hope that makes sense. So we have acceleration of B equal to acceleration of O plus acceleration of B relative to O. Acceleration of O is constant because the center of this whole circle doesn't move, right? So it's a fixed point. And then we're going to break this up into a tangential and normal component, this term over here. So the tangential component is going to be alpha BO crossed with R plus the normal component, which is going to be omega BO into omega BO crossed with R. Okay, and that's where the tangential acceleration of roller B comes from. So we're essentially trying to solve for this term over here. Okay, and then we have another omega over here, right? And we can solve for this by using the relative velocity, so the velocity of B relative to O, right? VO is 0 because point O is a stationary point, and then we just have omega BO crossed with R. So if we can solve for VP, then we can solve for that, and we can substitute that here, right? So let's try and solve our velocity problem. So we're first going to start with VA and VP, since we have the direction and the magnitude of VA, and then we can use that to help us solve for VP. So let's do our equation. VA is equal to VP plus VA relative to B, and we can break that down further into VA equal to VP plus omega AB crossed with R, right? So we don't know that, we don't know that. So let's try and use the vector triangle to help us solve the problem. So this is point B, that's point A. Then we have VA over here, and then to get VB, the direction of VB, we're going to use the fact that it's going through fixed axis rotation with the center of the circle, right? So we have the center of the circle O, and then we have point B over here. And then if you look at how this thing moves, right? So VA is pulling this thing down, right? And it's basically going to force this thing to rotate like that. So it's going to move kind of like that. So VP would have to be pointing towards the left, right? And because it's going through fixed axis rotation over here, VP is going to be perpendicular to this line OB. Okay, so VP is going to be like that, but let's assume that we didn't know the direction of VP for this case, right? And then, so just in case you didn't see, or you couldn't see how this thing was going to move, we can assume that we don't know the direction of VP. And then the relative velocity term, the VA relative to B, is going to be perpendicular to this line and could either point up or down. Then we're going to come back to our equation, which states that VA is equal to VB plus VA relative to B. And we know that VA is going to start at the tail of VB, and it's going to end at the head of VA relative to B. So we draw in the vector that we know VA, and VA must start at the tail of VB. So VB could either go that way or it could go that way, and it's perfectly horizontal. And VA must end at the head of VA relative to B. So VA relative to B goes in this direction over here. So it could either go up or down, but it's in this direction. So we can't draw, so it's either going to go down like that or it's going to go up like that, but we can't draw it in this direction and complete this triangle because VAP is slanted that way. Hope that kind of makes sense. right? So it can only go either this way or down this way, right? And our rule is that VA ends at the head of VA relative to B. So we're going to draw the head of VA relative to B pointing this way. Okay, I hope that makes sense. And then I'm just going to clean up the triangle and label everything. So this is going to be VA relative to B, and then this is going to be VB. Okay, then I'm going to look for vectors that are either horizontal or parallel. So VA over here is vertical. Wait, did I say horizontal or parallel? I meant horizontal or vertical. So VA is vertical, and then VB is horizontal, right? And then I'm going to draw an angle between one vector and the other vector that's either horizontal or parallel, vertical. So I'm going to call this angle theta, and then I'm going to call this angle alpha. And then I'm going to go into my diagram and I'm going to try and find either theta or alpha. And because this is a right angle triangle, once I find one angle, I'll be able to solve for VB and VA relative to B. And then I can use that to solve for omega AB. Okay, so coming to the diagram, I know that my relative velocity term, VA relative to B, is going to be perpendicular to the line AB. So I'm going to draw in VA relative to B, and it's pointing downwards. The vector is pointing downwards like that. Just going to shorten it a bit. And the angle that we want, I'm going to draw this as a complete triangle, right? And then the angle that we want is the angle that it makes with a vertical line, and the angle that it makes with a vertical line we called alpha, and the angle that it makes with a horizontal line we called theta. So I'm going to label those two angles and see which one is easier to solve for. So this one is alpha, and then I'm going to draw in a horizontal line. So this is alpha, and then this is theta, right? Cool. Then I know that this is perpendicular to that, and I can extend it further and say that it's also perpendicular on the side if need be. So I can find this angle over here. So I know that this distance from here to here is a distance r, and then this distance over here is also r, right? And then this is, let me call that phi. If that's phi, then the value of phi is equal to arctan of r over r, which is equal to the arctan of 1, which, if I'm not mistaken, is 45 degrees. I think that's correct. Yeah. So phi is 45 degrees. right? And then this is 90. Then if I call this angle here, gonna call it, if I call that psi, then psi is equal to 90 minus phi, sum of angles on a triangle, and then that will also be 45 degrees. And then alpha is equal to, because this entire angle here is 90, alpha will be equal to 90 minus phi, which is then again 45 degrees. So that angle over there is 45, right? And then that will give you that VA and VB are the same. Cool. So they're the same in magnitude. And then, so VB is equal to VA, but only in magnitude. Their directions are different. So, yeah, there will be a relative velocity between the two. And then we can use this equation, VA is equal to VB plus omega AB crossed with R. And now we have VA, we have VB, and we can solve for omega AB. Okay. And then we can also go back to the acceleration problem, right? The overarching acceleration problem, this one over here. So we have acceleration of A is equal to acceleration of B plus this alpha AB term. So alpha AB crossed with R plus omega AB into omega AB crossed with R, right? And we've solved for that. We still don't know this. And we can solve for this, right? We can solve for the acceleration of A. Well, we're told that the velocity of A, right? So if rho A has a downward velocity of 1.2 meters per second and this motion is constant over a small time interval, so that tells us that the acceleration of A is actually 0, right? So we just need to find the acceleration of B, right? But they're asking us for the tangential acceleration of B, right? And going back to this equation over here, right, we have this part, which is the tangential, and we have this part, which is the normal. So the tangential, we can rewrite it in terms of the tangential and the normal of B, so we can substitute that in. We're going to have alpha BO crossed with R plus omega BO into omega BO crossed with R plus alpha AB crossed with R plus omega AB into omega AB crossed with R. So we have this term, we have the omega AB. We don't know that. And we also don't know this, and we don't know that. But the omega BO we can solve for by saying VB is equal to VO plus VB relative to O. We know that O is a stationary point, so that's 0. And then this will be equal to omega BO crossed with R, right? And we've solved for VB previously. And then we can solve for omega BO, right? And we can work out the normal acceleration for B, right? Which is just going to be omega BO into omega b O crossed with r, which is just this term over here, right? So going back to our acceleration equation, we have 0 is equal to BO crossed with r, right? So this is the tangential, and they want us to solve for the tangential. They don't want us to solve for alpha, so I'm just going to write it as a b tangential plus omega BO into omega BO crossed with r plus alpha AB plus alpha AB crossed with r plus omega AB into omega AB crossed with r, right? So we have that, we're looking for that, we have that, we're looking for that, right? Now, this tangential component of the acceleration, in order to just write it alone, we need to know its direction, right? So if this had two components, we'd need to know each of those components, right? So if we look at, because we want to write everything as a vector and compare I hat and I hat and j hat and j hat, so we need to then break this down into a vector. So if we look at OP, right, and we know that this thing has some sort of alpha in this direction, right, then the tangential acceleration would be like that, and then the normal acceleration would be like that. So remember, normal always points towards the center of the circle, and then if we draw an arc, so if we draw that circular path that B is going to follow, you can see that the tangential component is tangent to the arc, which makes sense, right? So it's either going to be in this direction or in that direction, but we've established that this thing is moving this way, right? So your thing is going to be in that direction. So cool. We're gonna have 0 is equal to AB tangential in the I direction plus whatever this gives me, and you can see that it's in the J direction. So I'm just gonna call this okay, let me just write it as is. So omega BO times r. So we're using we're not going to use vectors for this in this case. We're just going to use scalar multiplication because we already know the direction. But you could use vectors and you'll end up with the same results. And then we have alpha AB crossed with r. So in this case, you'll most likely have to use vectors, and then plus omega AB, vectors again, omega AB crossed with r. Okay, and then all you need to do then is compare I hats together. You'll get one equation, j hats, you'll get another equation, and then use simultaneous equations to solve.